Hello, welcome to our lesson on circular functions. So we're going to build today on some of the trig ratios we've looked at previously and how we can use the unit circle in even further ways. So just to recap, we've talked about sine, cosine, and tangent being trig ratios we can write from a right triangle. So for instance, if I was looking at this angle here, which we're calling theta, if I wanted to write ratio for the sine of theta, we know that the sine is a ratio of the opposite leg over the hypotenuse. So in this case, again, just opposite leg over hypotenuse. Cosine for our angle we know is a ratio of the adjacent leg over the hypotenuse. And the tangent we know is a ratio of the opposite leg over the adjacent leg. So we have technically not just these three ratios we can write, but we have six ratios. We have now to introduce the cosecant, secant, and cotangent. And these three new ones are just the reciprocal of the three that we already know. So they are reciprocals. So cosecant, let me just try to coordinate these. The cosecant ratio is the reciprocal of the sine ratio. So if I want to write a ratio for cosecant, instead of opposite over hypotenuse, it's going to be hypotenuse over the opposite leg. Again, cosecant being the reciprocal of sine. And if I want the secant ratio, it's the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, then the secant is the hypotenuse over the adjacent. And then lastly here, new color, cotangent is going to be the reciprocal of tangent. And that makes sense. Unfortunately, it would make sense for cosine and cosecant to go together and sine and secant to go together name-wise, but they don't. So cotangent being the reciprocal of tangent, hopefully name-wise makes sense. The other two, you're going to have to try to straighten those out in your heads. But this one will be the adjacent over the opposite. Okay. Now, when we're looking at right triangle where our hypotenuse is 1, remember we saw that connection to the unit circle with the radius length of 1, we can calculate some exact measures. So let's just try writing these ratios. Again, the sine of 30, which I'm hoping we know because this is one that comes off of our unit circle. The sine for 30 degrees, if we didn't, also we could find the missing sides here using the pattern of our 30, 60, 90s. So we know that this shorter leg is going to be half of the hypotenuse, and then the longer leg would be that shorter leg length multiplied by a radical 3, so this ends up being a radical 3 over 2. So if I want to write the sine for 30, and I didn't have the unit circle, but I knew my 30, 60, 90 patterns, I could still write my ratio as my opposite side over my hypotenuse. So in this case, the 1/2 over 1 would just be a half. And then if I wanted the cosine for 30 degrees, that would be the adjacent side over the hypotenuse. So again, dividing by 1 means we're just going to be looking at a radical 3 over 2. And then if I wanted the tangents, this is not one we looked at from the unit circle, but if I wanted the tangent for 30 degrees we know is the opposite leg over the adjacent leg. So in this case, it's almost like taking the sine over the cosine. Because our hypotenuse is 1, it doesn't change those values. So the opposite over the adjacent in this case ends up being turned my eraser on, a 1/2 divided by a radical 3 over 2. So now we have what we call a complex fraction. We don't want to leave fractions within a fraction. So there's a couple ways to handle this. We can just perform the operation, I think would be the easiest way. So this says that 1/2 is being divided by radical 3 over 2. Well, we don't divide fractions, we multiply by the reciprocal. So this could be rewritten as 1/2 being multiplied by 2 over radical 3. In which case our 2's are going to reduce out there, and so we have 1 over radical 3. But that should really be rationalized. So if we go ahead and rationalize this by multiplying by radical 3, then we end up with the final version for our tangent of 30, which is going to be 1 radical 3 over 3. So there's our tangent of 30. Clearly not as simple as the others. Now, the three new ratios are just reciprocals. So if we can find sine, cosine, and tangent either from our right triangle or eventually from our unit circle, then we're just going to flip those over to find the cosecant, secant, and cotangent because, again, they are just reciprocals. So if the sine of 30 is a half, then the cosecant for 30 is the reciprocal of a half, which is going to be 2 over 1, or just 2. The secant for 30, again, is the reciprocal of the cosine. So that's going to be 2 over radical 3. Now, of course, that has to be rationalized. So if we multiply by radical 3 over radical 3, then the simplified form is going to be 2 oops, wanted to go back to red. 2 radical 3 in the numerator, and then just 3 in our denominator. I don't know why I circled or boxed that one in down there. Maybe this one too, just so it's clear what the answer is. And then lastly, we want the ratio for the cotangent of 30 degrees. So cotangent I know is going to be the reciprocal of tangent. Now, I could take the reciprocal of this form here, but then that's going to require rationalizing the denominator. Or I could take the reciprocal of this form here, which is already rationalized. So for the cotangent of 30, we're going to say radical 3 over 1, which would obviously just be a radical 3. Okay, now we want to generalize this so that I don't have to find missing sides of the right triangle. If we have this information already in our unit circle, then we should be able to find all 6 trig ratios from our unit circle. So instead of calling our sine opposite over hypotenuse, in the unit circle, we said we could identify the sine as just the y coordinate where that angle met or intersected the unit circle, and the same for cosine, we could say that it's just the x. So we want to generalize in the same way the other trig ratios, okay? So if we took, again, our hypotenuse length of 1 being like our radius length of 1, if we took our triangle and put it into the unit circle, this opposite side over our hypotenuse of 1 and this adjacent side over hypotenuse of 1, that hypotenuse of 1 changed nothing. So when I wanted to write the sine for my angle, it would just be that opposite side. Or if I wanted to write the cosine for my angle, it's just that adjacent side. And that adjacent side is that distance along the x, which is why it became this coordinate here. And that opposite side is that distance along the y, which is why it became the y coordinate here. So when we're looking at this on the unit circle, we can simply say that the sine for our angle ends up being the y value in that coordinate where the angle intersects the unit circle. And we said if we wanted the cosine, we were just going to find the x value where that coordinate intersected the unit circle. And again, that y value, right, that y value that we saw happening here was just that opposite side that we had here. And we see this up here as well, right? The y value, the sine that we have here, that is just that opposite side that we have here. So same thing for the x value here, that's just the adjacent side that we have here. So when I want to write the tangent, instead of saying it's the opposite side over the adjacent side, we can say it's a ratio of that y value over that x value. So instead of looking at the triangle and picking out the 1/2 in radical 3 over 2, we can do that here using our sine and cosine. So we're going to say that tangent is going to be equal to a ratio of the y coordinate divided by the x coordinate. Okay, it's y over x. And then cosecant, secant, cotangent, those are all just reciprocals. So if I want to find the cosecant for an angle, I'm going to find the y coordinate and flip it over. So the reciprocal of y, which is technically y over 1, would be 1 over y. Okay, or if I wanted the secant, again, this is the reciprocal of our cosine function. So if cosine is x, this would be 1 over x. So it's 1 over x, and that's the general way to say it, although just like we had up here, right, I don't want to have to go 1 over 1/2 if that's my y value in my reciprocal. I can just take whatever I have and flip it over. Okay. So these are general reciprocals, but we can just take that y value and flip it to get cosecant. We can take that x value and flip it to get secant. And we could take our y over x and flip it to get cotangent. So cotangent is going to be x over y. Now because these functions of x and y here all come from the unit circle, they are referred to as circular functions. Right, where here we were just looking at ratios. Now that we introduce x and y, we're talking about functions. Okay, so these circular functions are all things we should be able to identify from our unit circle when we're talking about our special angles. Our 30-degree angle and all of the other angles that have 30-degree reference angles. Same for 45 degrees and all angles that have 45-degree reference angles, and then the same for 60. And then also we want to add in there our quadrantal angles like the 90, the 180, the 270. And so let's try to use the unit circle and build off of what we did before and then add on the new stuff. Okay, so if I asked a question like find the coordinate, or gave you a problem that said find the coordinates where the terminal side of a 300-degree angle intersects the unit circle, it's not so bad. We're just looking for coordinates. So here's our 300-degree angle. These are the coordinates where we intersect the unit circle. That's not bad. So our coordinates would be 1/2 and negative radical 3 over 2. And being able to find those coordinates are helpful because remember, those coordinates tell us so much. We know that each one of those coordinates gives us directly the cosine for our angle followed by the sine for our angle. So we know from our previous lesson this is going to be our x, this is going to be our y. And now I also know the tangent is a ratio of that y value over that x value, and that cotangent, cosecant, and secant are all going to be reciprocals of those three. So now this one, it should be review as well. If I said to find the exact value for the sine of 150, then I'm looking for 150 degrees. Here's my angle 150, and then here's the whole coordinate. If I want the sine, remember that's just the y value. So I know that the sine for 150 is going to be exactly 1/2. And so let me say that here. The sine for 150 degrees is exactly 1/2. And even if you weren't sure, I don't know why you wouldn't be. This is not that complicated of a process, but you could always use your calculator to verify. So we make sure our calculator is in degree mode, and then let's just verify. If in fact I wanted to know the sine for 150 degrees, it better be an exact 1/2, and there it is. Okay. So here, what if I wanted the exact value for the cosine of negative 135? Well, I have positive angles measured here, but remember negative 135, a couple ways to do this. So if positive 135 goes 90 degrees and then another 30 and another 15 in that direction, a negative 135 would do the same thing in the opposite direction. So I would go 90, 30, and then another 15, which means that 135 and 225, those are coterminal angles. They are the same place. So I'm looking at, oops, undid one too many, negative 135 being coterminal to positive 225. The other way to do that is just to take your angle and add 360. Remember, coterminal angles differ by 360. So I end up with 225 degrees. Okay, so really what I'm looking for is the cosine for 225 degrees. And so I go to my unit circle again, 225 degrees. That is this angle right here. Cosine is the x value in that coordinate. So that's going to be exactly negative radical 2 over 2. So back here, negative radical 2 over 2. Now let's say you wanted to use your calculator to confirm that one. So if you put in the cosine of 225, it's going to give you this decimal. Well, what you want to confirm is that negative radical 2 divided by 2 is in fact the same decimal approximation, and there it is. So another way for you to use your calculator to confirm. Alright, now finally a new one, because those are all review. If I said to find the exact value for the tangent of 210. So tangent, gotta remember that tangent is a fraction, so maybe I should have made notes up here. That the sine, we are looking for the y value in the coordinate. For cosine, we're looking for the x value in the coordinate. And for tangent, pen colors, we're taking a ratio of the y value over the x value. So tangent of 210 degrees happens to be right here. So I want to take the y value and divide it by the x value. So if I take my y value, it's negative 1/2, and divide it by my x value, which was negative radical 3 over 2. The negative is going to make a positive, and remember, we have a fraction divided by another fraction, so we actually want to multiply by the reciprocal. So it's going to be negative 1/2 multiplied by 2 over negative radical 3. It doesn't really matter what those negatives are. They're going to cancel, make a positive. So they're going to make a positive, and I'm going to end up with 1 over radical 3, which rationalizes when we multiply. And we did this work earlier. Eventually you could skip this work because you know it. It's totally fine. You're going to end up with radical 3 over 3. So we're going to say the exact value for the tangent of 210 degrees is radical 3 over 3. And your calculator, remember, could give you a decimal approximation, but these exact values are always going to be preferred. And I boxed that one in because it was a lot of work and I wanted to make sure it was clear what the answer was. But now I have OCD problems and I need to box the rest of these in. Okay, let's try the next one. So next one, we're looking for the exact value for the secant of 60. So we have to remember secant is the reciprocal of cosine. So cosine is x. This is the reciprocal of cosine. Since cosine is x, then we're looking at 1 over x. And so we can either make a fraction of 1 over the x value, or we can just take the reciprocal of that x value, whatever is going to be easier. So let's look for 60 degrees. Again, 60 degrees here on our unit circle. And the more you can do this without actually having to look at the paper, that's going to be better for you. So like if you know your little hand trick and you can find 60 degrees and see what your cosine is and then flip that over, that's going to be to your benefit. But since I have the picture here, again, we're looking for the reciprocal of cosine, cosine being our x value. So the reciprocal of 1/2 is just going to be 2. So we're going to say that the secant for 60 degrees is exactly 2. Again, this would be a really easy one to confirm with your calculator. So let's go secant of 60, and there it is, a nice exact 2. Okay, let's try the next one. So we're looking for the exact value for the cosecant of negative 225. So first, cosecant is the reciprocal for sine. So this is the reciprocal of sine, which means we're looking for sine being the y value, we're looking for the reciprocal of the y value. So that'd be 1 over y. So we can make a fraction of 1 over the y value, or we can just flip that y value. But we got to find out where we are first on the unit circle. So it's negative 225. That's not actually where I want to be. Make it a different color here. If I add 360 to this, I know that I'm looking at actually a positive 135. So I'm going to go to 135 degrees. And we were there a little bit ago. Here's my 135. Since I want the reciprocal of y, here's my 135, here's my y value. I'm just going to flip that over. So I'm looking at, making a mess of my unit circle, 2 over radical 2. So this is going to be 2 divided by radical 2. That gets rationalized. So radical 2 times radical 2, and then we end up with, oh my gosh, too many color changes. 2 radical 2 in the numerator, and then 2 in the denominator, so those are going to reduce out to just a radical 2. So we're going to say that the cosecant for negative 225 degrees is exactly radical 2. And because there's a little bit of work involved, again, it might not be a bad idea to just check with your calculator. So we're looking for the cosecant of negative 225, and let's confirm that that is the same as radical 2, and boom, you got it, confirmed. Alright, trucking right along. Hopefully you're feeling okay about this. So cotangent for 180. Cotangent is the reciprocal of tangent. So I want the reciprocal of tangent. Got to remember what tangent is. So tangent is y over x, which means cotangent is going to be the x value over the y value. So I'm going to go to 180. And here's my 180 degrees. If I want the reciprocal of tangent, again, I'm taking the x value and writing it as a fraction over the y value. So negative 1 over 0. Go back here. Sorry, I'm scrolling and I'm making a mess. If I take my x value and divide it by my y value, in this case, I end up with negative 1 over 0. And dividing by 0 is not something that's defined. And so 0 in the denominator being undefined means that the cotangent for 180 degrees is undefined. It is not possible to write or divide by 0 or to write that fraction. So, and wow, I don't know how I just ended up in my photos, but okay. So we're going to say that the cotangent for 180 degrees is undefined. Again, this is something that can be double checked with your calculator. Try to calculate it. Try to ask your calculator to find the cotangent of 180 degrees. If you can type it in there correctly, and it's going to also confirm that that's undefined. So I'm going to go back to the front here because I left off an important detail. Anytime you're dealing with with a fraction, it's important to remember that the bottom of the fraction cannot be 0. Division by 0 isn't defined. So we want to state for the record here that when we're looking for tangent, that x cannot equal 0 because that's the bottom of the fraction here. Cosecant, y cannot equal 0. Here again, x cannot equal 0, and then here, y cannot equal 0. The bottom of our fraction isn't allowed to be 0. Dividing by 0 isn't something that's defined. So if any time we are writing a ratio for tangent, cosecant, secant, or cotangent, and we end up with a 0 in the bottom of the fraction, it's going to be undefined. Again, luckily that's something we can verify with the calculator. Alright, we're almost there. Let's try just a couple more. Next one, we're looking for the exact value for the secant of 45 degrees. So the secant, that is the reciprocal of cosine. Cosine being the x value means this is going to be 1 over that x value. So we go to 45 degrees, find the x value, and flip it over. So the reciprocal of radical 2 is, or radical 2 over 2 is the same thing that we just did in the number 6 up here. But just so you can have the work again, so it's 2 divided by radical 2, which ends up being radical 2 after we rationalize. So we're going to say that the exact value for the secant, I don't know why I put a, sorry, a secant of 45 degrees is going to be exactly radical 2. And again, calculator could be used to confirm that. Alright, just got a couple left. If you're feeling pretty good about this, go ahead and pause the video and try out the last two. Otherwise, we can just finish these off. So cosecant. Cosecant is going to be the reciprocal of sine. Since the sine is the y value, this is going to be 1 over the y value. We're going to 45 degrees. We just saw that 45 degrees. At 45, that's where our x and our y are the same. So if I want the cosecant for 45 degrees, again, I want the reciprocal of radical 2 over 2, which is 2 over radical 2, and that's going to simplify to our radical 2. So we're going to say cosecant of 45 degrees is exactly radical 2. And since we have it in a minute, let's just verify. Nope, that's secant. Goodness. Cosecant of 45 degrees is the same as radical 2, which is 1.141-ish. Alright, last one. We're going to try to find the exact value for the tangent of 330. So tangent, no reciprocal, but is a ratio of the y value divided by the x value. So at 330 degrees, 330 is here, so we're going to take this y value of negative 1/2, divide it by this x value, which is radical 3 over 2. So negative 1/2 divided by radical 3 over 2. Negative 1/2 divided by radical 3. Again, we've done this work already a few times, but if you want to see it again, you're going to, instead of dividing the two fractions, multiply by the reciprocal. So you keep that top fraction the same, and then you're writing this as a multiply problem. Multiply by the reciprocal, which is going to be 2 over radical 3. Those reduce out, so it's still a negative 1 over radical 3. And once that gets rationalized, multiplying by radical 3 on the top is going to give you radical 3. Multiplying by radical 3 on the bottom is going to be just a 3. So we're going to say the exact value for the tangent of 330 degrees is exactly negative radical 3 divided by 3. And for good measure, let's go ahead and use the calculator to verify. Hey calculator, what is the tangent for 330? And let's make sure negative square root of 3 divided by 3 is the same. And there you go. So verified. Okay? So we want to be using the unit circle to find exact values for our 30, 45, and 60 degree reference angles, or angles that have 30, 45, and 60 degree reference angles for our quadrantal angles. Remember, bottoms of our fractions can't be 0, so those would be undefined. And all of these exact values could be confirmed using a decimal approximation from the calculator. Just make sure your calculator's in degree mode. Okay, so just a slow build on everything we've done so far, and the more you can do without having to reference unit circle, the better. So just to kind of go back to this last one, so we were looking at 330 degrees. If you're trying to do this without looking at your unit circle, what you should be in your head saying to yourself is, okay, 330, that has a 30 degree reference angle. So I know my coordinates are going to be radical 3 over 2 and 1/2. But if I'm in quadrant 4, which is where a 330 degree angle would be, that this would have to be negative. So ideally, you're able to come up with these coordinates without having to use your unit circle. So in the beginning, fine, use it, whatever, but if you can, the more you can wean yourself off, the better. So yeah, do some practice with that. Hopefully you've got enough to get going. If you have any questions, by all means, reach out. And until next time, take care.